Okay.
There you go. All right. Hey, hi, how are you? Okay, so here's the deal, all right? I have no idea what I'm doing. None whatsoever. But I got to do this for like this biology thing. So anytime you're mixing chemicals and stuff, I guess you need like protection. My kit came with like some glasses, but it's sunny outside, so I got these. So we're going to take this hydrogen peroxide. What that kind of is like water, but it's got an extra oxygen molecule, and it wants to get rid of it. It really does, badly. So I'm going to try to help it. To help it, I got this stuff. This is just some active dry yeast. Nothing fancy, right? But you put the two of them together, and it releases the oxygen, kind of turns into water, and you get like foam, right? Well, one of the things that I wanted to see was if I increase or reduce the pH, what's that going to do to the hydrogen peroxide trying to release it with the enzymes in the yeast, the catalyst, right? So I've got right here, I got this vinegar, and if you're not a science buff like me, not a science buff, but I read on the internet, you combine vinegar with hydrogen peroxide, you get this stuff called, hang on.
Peracetic acid.
Parasite, I don't know. Anyways, it's going to be a little bit higher up on the acidic level. So to do this, all right, I want to have a control. So I numbered these things 1, 2, and 3. Number 1 is just going to be 5 mil. Actually, no, we changed the numbers so I can do small enough figures here. It's 2 milliliters of hydrogen peroxide. Okay, just 2 in each of these bottles. There we go. There.
What's the dilution of the hydrogen peroxide?
Oh yeah, my bad. Okay, so my wife, like the science person, she wants me to remind everybody I'm using traditional standard over-the-counter 3% hydrogen peroxide. So nothing fancy. I wanted to get the 6% stuff, but I couldn't find it. So, all right. So I got the hydrogen peroxide. Now we got to have a control, right? Our control, it's not simply orange; it's simply water. Alright, so everybody's going to get 1 milliliter of my buffering solution. So my buffering solution for the control is nothing fancy but 1 milliliter of water. Everybody else is going to get 1 milliliter something else, but I want to keep those numbers consistent. So 1 milliliter of water into pipe number 1. Number 2 is going to get the vinegar, okay? Now, when you're doing this, you got to be careful, do it in open air, because that paradoxidase, or whatever the heck it's called, when you combine these two together, you can get like this caustic gas. And if you breathe that in, it can cause problems. If it touches your skin, more problems. You know, vinegar by itself, peroxide by itself, not that big of a deal. You mix them together, you can get some crazy stuff. And the last one, this is why my son's standing all the way back there. This is going to be bleach. You want to talk about some caustic stuff, we're going to add this to the hydrogen peroxide. And that you really don't want to breathe in. So, just like I said, 1 milliliter each. Now, one thing that I wanted to show you real quick before it goes down is the bleach has already started the oxygenation process, right? Maybe I'm not saying it right, but you can see all these bubbles down there. It looks like carbonated water. That's because the bleach is already starting that process. The hydrogen peroxide is already reaching out oxygen. So, what I wanted to do was, you know, make this more of an alkaline-based solution to see how the enzyme would react. But what's actually going to happen, and you know, hey, failed experiments happen, is I'm not going to have as much oxygen to release from the yeast anyway, so it's going to kind of nullify itself. So this is what I call a negative, okay? So we got our control, right here, the water. That's where everything's going to work the same way it normally would. We got our negative, right? That's the bleach. It's already removing some of the oxygen. And we got our actual test experiment, and that's the vinegar to try to increase the acidity of the solution. So, to do this, what I'm going to do, I reduce these figures down so that I can actually measure how big the foam head is on each of these solutions. Now, because I reduce those figures, when you go online and you try to look up stuff, they're going to say, you know, 5 milliliters of hydrogen peroxide and a quarter of a tablespoon, or whatever the heck TSP means, of yeast. But because I'm shrinking those numbers down, I don't want about half, okay? About 1/8. So I'm going to dump that in there.
So that's 1/8 of a teaspoon.
Yeah, the TSP, which coincidentally in the federal government, that's like a 401k. So I'm going to give that 1/8 to each of these things. And you can see my foam's already starting to rise a little bit here. and just to kind of see what's going to happen. I'm going to measure it out. I got my handy dandy ruler next to me. All right. And what's nice about this is it's a really forgiving experiment. And what I mean by that is it's going to be really easy for me to measure the foam. If I left this out there for like 5-10 minutes, the chemicals and the yeast and everything else, it kind of makes a like a sticky substance, right? So it's just going to stick on that glass. And even without me measuring, you can see what's going on here, okay? So the yeast, it really wants to have an ideal pH, okay? If you get a little bit of extra acid, it's not going to function as well. You get a more alkaline base situation, I mean, it's barely going to react at all. And you can see that really easy right here on this simple scale. We take out our handy dandy ruler, and we can measure that foam head from the bottom of this test tube all the way up. And we get about 11 inches, and that's just our control, that's just water. Increasing our acidity is going to give us about 9 inches. Okay, those are the nieces and nephews who are coming over here. They're coming over for the other experiment. All right, and then my last one, my base, that's a lot less. That's only about 6 centimeters. And the reason for that, again, is that part of it is the enzymes have already been doing a lot of work, or the enzymes don't have a whole lot of work to do because the oxygenation process has already started, and they don't really like the fact that you're a heavy base environment. So really, that's the experiment for number one. We have you know, countable, qualifiable proof. But what experiment is good if you can't have a little bit of fun, right? So this bottle of water, I'm going to use this for something else, okay? I'm going to take a little bit of this water, I'm going to pour it in here, okay? The rest of it, I don't know, maybe I'll just spray my audience with it a little bit. If you want to screw around, you can see all the kids, okay? So what I'm going to do with this, right, is I'm going to take a good heaping of this yeast. I mean a good heaping. I don't even know what size this is.
The big one is a tablespoon.
Right. I'll give it another one. I want it nice and concentrated. I was kind of playing around with this earlier. I got this little guy. That's not good enough for me. Alright, so what I want to do is I want to take this, and maybe I can get a demonstrator. Here, Chloe, can you come up here? I want you to stir this up really good.
Okay.
Stir it up really good till it just looks like a solution. All it is yeast and water. It's not going to hurt you, I promise. Alright?
Okay.
So, now the next thing, we got our giant bottle here. Alright, what could be good to do with this giant bottle? Well, remember that hydrogen peroxide stuff?
Yeah. Sure.
If you notice, I'm not measuring anything because at this point I don't even care, and as the teacher, you probably already know what I'm doing. I'm going to fill this thing a little bit here. I'd say right about there seems good, probably a little bit excessive, but you know what? What's fun about science if you can't be a little excessive? Alright, I'm going to take this soap. I've only got so much left in this bottle. So I'm just going to squeeze it in there.
Wait, that's what you need?
Yeah, whoa! Bubble action. Alright, so now, can I get another person? Yeah, come on over here, Amber. Be careful, alright? We don't want bubbles. Just stir it up a little bit. Get a little bit of action going on. So what we're doing here is we're doing this whole oxygenation process with the yeast and the hydrogen peroxide on a much grander scale, and it's going to be a lot more fun if we do this correctly. All right, I think you're good. We got this nice little blue hue. You know, a lot of times they want you to use whatchamacallit?
Food coloring.
Food coloring. Thank you. My assistant's really assisting. But I didn't grab any, and I don't think it's really necessary. So here's the deal, all right? You really want to be careful when you do this because chemical reactions happen, right? Does anybody have an idea about what's about to happen? We saw my little experiment right here with the bubbles, right? Anybody want to take a guess as to why I put the soap inside that thing? Chloe. It's not going to explode. Amber.
All the bubbles are going to shoot.
All those bubbles. Hopefully, we're going to make a mess of things, right? Now, safety first. I want everybody to stand back a little bit more.
Andy, go back, honey.
Past that line. That's good right there. I'm going to pour this solution in. Looks pretty good, Chloe. Good job. And cross our fingers that this works because we're all doing this all in one take, right? Ready? All right, let's see. Let's see what happens. Fingers crossed that we can get some good reaction here. It's starting to flow. It's coming. We got a little bit. Oh, well, that's not nearly as strong as I'd hoped, but here's the thing. When you go and you see this stuff on the internet, what they're actually using is a higher percentage base of hydrogen peroxide. And that's really where you're getting that extra massive like foam flow. And if you come in a little bit, Mom, or wife, or whatever you want to call it, you can see a little bit, there's actually heat coming off of this foam. This process of removing the oxygen from the hydrogen peroxide actually does create heat.
That's
and
cool.
As the process
It is.
goes
It's a little
through,
warmer here.
that's the ATP.
That's going to
So if you come
No.
one at a time, all right, do not touch that foam. But you can come a little bit closer, and you can actually feel a little heat coming off of that. Not quite like a campfire, but
That's
a little
so
bit.
cool. That's
Andy,
really cool.
do not touch the foam. That's the most important thing.
You can come close where Chloe was.
Stick your hand up there quickly now.
Andy, yeah,
Don't
there.
touch the foam.
That's
You
close
feel
enough,
how it's
buddy.
a little bit warmer?
Yeah.
All right. Yep. Real quick. Do not touch the foam. Do not touch the foam.
Oh my god.
I know. Right? Go ahead, Caitlin. Yep.
It's hot. I can't feel anything.
Good.
Oh yeah. Oh wow.
Yep, there you go. Don't touch the foam, but I mean our reaction's still going. So yep, just like that.
So
You feel how it's a little bit warm?
All right, Lo, move back.
All right. Well, maybe it's coming out a little bit. So hey, that's my experiment, and we did some things. So the good news about having it filmed is I have it all on posterity. I got the numbers, the figures. I'm gonna write you up something fancy. But listen, hey, Professor, this has been a great course, and I've had a great time. So we're gonna say goodbye for now. And